Hey there everyone, welcome back to another video. This is IGCSE Chemistry, CIE, and today we'll be looking at electrochemistry. Here with me today is Daniel, a very close friend of mine. So let's start. We'll start by looking at electrolysis, the general principles. So when an electric current is passed through a molten ionic compound, the compound decomposes or breaks down. The process also occurs for aqueous solutions of ionic compounds. Covalent compounds cannot conduct electricity, hence they do not undergo electrolysis. Ionic compounds in the solid state cannot conduct electricity either, since they have no free ions that can move and carry their charge. So the electrical conductivity of ionic compounds, as we see, we have the solids; they do not have any free ions which will conduct the charge. But when it is melted, it is called molten. Since molten is in a liquid state, they can move around and conduct the charge. So key terms used in a simple electrolytic cell. Electrode is a rod of metal or graphite through which an electric current flows into or out of an electrolyte. Electrolyte is the ionic compound in a molten or dissolved solution that conducts the electricity. Anode is a positive electrode of an electrolysis cell. Anion is a negatively charged ion which is attracted to the anode. Cathode is the negative electrode of an electrolysis cell. Cation is a positively charged ion which is attracted to the cathode. Okay, over to Daniel.
Okay, uh, metals and hydrogen form positively charged ions, and so either a metal or hydrogen gas is formed at the cathode. Non-metals form negatively charged ions, and so non-metals except hydrogen are formed at the anode. Example: use the panic mnemonic to remember which electrode is the positive and which one is the negative. Positive is anode, negative is cathode.
Okay, moving on to electrolysis, charge transfer. So this one is for extended students only, but if you like, you can still watch it. So during electrolysis, current needs to flow around the circuit. In order for this to happen, charge must be transferred around the circuit. Current is a measure of the rate of flow of charge by charge carriers. The power supply provides the cathode with a supply of electrons, causing it to become negatively charged. As we discussed, cathode is a negatively charged electrode. Positive ions, cations, in the electrolyte move towards the cathode where they gain electrons. Negative ions, which are anions, in the electrolyte move towards the anode, the positive electrolyte, where they lose electrons. The electrons move from the anode back towards the power supply. So in a complete circuit, electrons are the charge carriers in the external circuit. Ions are the charge carriers in the electrolyte. So yes, this is a diagram. This is our electrolyte cell. We have our cathode here, we have our anode here, we have our electrolytic solution, which is NaCl in this case. Our anions will be Cl, chlorine, because they are negatively charged. Cations will be sodium because they are positively charged. And then the flow of electrons is from the cathode to the anode. So from the negatively charged to the positively charged. And over to Daniel.
Electrolysis of molten compounds. A binary ionic compound is one consisting of just two elements joined together by ionic bonding. When these compounds undergo electrolysis, they always produce their corresponding elements. To predict the products made at each electrode, first identify the ions. The positive ion will migrate towards the cathode, and the negative ion will migrate towards the anode. Therefore, the cathode product will always be the metal, and the product formed at the anode will always be the non-metal. Example: electrolysis of molten lead to bromide. Method. So the method we use to carry out the electrolysis of molten lead to bromide is to add the lead to bromide into a beaker and heat it so it will turn molten, allowing ions to be free to move and conduct an electric charge. Then we add two graphite rods as the electrodes and connect this to a power pack or battery. Turn on the power pack or battery and allow electrolysis to take place. Negative bromide ions move to the positive electrode, the anode, and each loses one electron to form bromine molecules. There is bubbling at the anode as brown bromine gas is given off. Positive lead ions move to the negative electrode and gain electrons to form a gray lead metal which deposits on the surface of the electrode.
Okay, so this is what Daniel was talking about. So yeah, just look at it, pause the video and look at it, and let's move on. Okay, worked example. Identify the products formed at the anode and cathode during the electrolysis of molten potassium chloride. Okay, so do this, and then the answer to this question will be the ions present are potassium and chloride. The chloride ions are attracted to the anode and form chlorine gas. The potassium ions are attracted to the cathode and form potassium metal. Remember that electrodes need to be inert, such as graphite or platinum, so that they don't participate in side reactions with the electrolyte. Moving on, electrolysis of aqueous sodium chloride and dilute sulfuric acid. Aqueous sodium chloride. Brian is okay. Wait, I would like to hand over to Daniel for now.
Brine is okay. So the electrolysis of aqueous sodium chloride and dilute sulfuric acid. Aqueous sodium chloride. Brine is a concentrated solution of aqueous sodium chloride. So you can say aqueous sodium chloride or brine. It can be electrolyzed using inert electrodes made from platinum or carbon or graphite. When electrolyzed, it produces bubbles of gas at both electrodes as chlorine and hydrogen are produced, leaving behind sodium hydroxide solution. These substances all have important industrial uses. Chlorine is used to make bleach, hydrogen is used to make margarine, sodium hydroxide is used to make soap and detergents. The product at the negative electrode, the positive hydrogen ions are discharged at the cathode as they are less reactive than sodium ions. The positive hydrogen ions gain electrons to form hydrogen gas. At the electrode, the chlorine ions are discharged at the anode. At the electrode, the chlorine ions are discharged at the anode. They lose electrons and chlorine gas forms. The sodium and hydroxide ions remain behind and form sodium hydroxide. This is just a diagram of all that I've been explaining.
Okay, so let's
Then
look at
for the
yeah
then
dilute
for the
sulfuric acid.
electric yeah for the electrolysis of dilute sulfuric acid. Dilute sulfuric acid can be electrolyzed using inert electrodes made from platinum or carbon or graphite, just the same as for aqueous sodium hydroxide. Bubbles of gas are seen at both electrodes. The product at the negative electrode. The hydrogen ions are attached in the cathode. Then they gain electrons and form hydrogen gas. And the product of the positive electrode, hydroxide ions are attached to the anode and they form oxygen gas and water. Over to Prasanna.
Okay, so let's look at determining which gas is produced or what gas is produced. So if the gas produced at the anode relights a glowing splint, that's the key word there, glowing splint, dip into a sample of the gas, then the gas is oxygen. This is just a diagrammatic representation. If a glowing splint is there, that means it's a oxygen gas. If the gas produced at the anode bleaches damp litmus paper, then the gas is chlorine. The color of the litmus paper is usually blue. This is the representation to show from blue to red to white. White is basically bleached. Okay, if the gas produced at the cathode burns with a pop, with, when a sample is lit with a lighted splint, then the gas is hydrogen. The key word here is the lighted. So this is hydrogen gas when a pop sound is heard. Electrolysis of aqueous solutions. This is for extended students again, but you can watch if you want. Aqueous solutions will always have water present. In the electrolysis of aqueous solutions, the water molecules dissociate, producing hydrogen, hydrogen and hydroxide ions. So H2O is basically H plus OH minus. These ions are also involved in the process and their chemistry must be considered. We now have an electrolyte that contains ions from the compound plus ions from the water. Which ions get discharged and at which electrode depends on the relative reactivity of the elements involved. Concentrated and dilute solutions of the same compound give different products. For anions, the more concentrated ion will tend to get discharged over a more dilute ion, the positive electrode or the anode. Negatively charged OH ions and non-metals ions are attracted to the positive electrode. If halide ions are basically halogens that are in the seventh group, such as Cl minus, Br minus, I minus, and OH minus are present, then the halide ion is discharged at the anode. It loses, sorry, it loses electrons and forms a halogen, chlorine, bromine, or iodine. If no halide ions are present, then OH minus or hydroxide is discharged at the anode, loses electrons and forms oxygen gas. In both the cases, the other negative ion remains in solution. The concentration of the solution also affects which ion is discharged. If a concentrated halide solution is being electrolyzed, the halogen forms at the anode. If a dilute halide solution is being electrolyzed, oxygen is formed. For example, for a concentrated solution of barium chloride, the chlorine ions are discharged more readily than the hydroxide ions, so chlorine gas is produced at the anode. If the solution is dilute, however, only the hydroxide ion is discharged, and so oxygen would be formed at the negative electrode or the cathode. Positively charged hydrogen and metal ions are attracted to the negative electrode but will only gain one electron. Either hydrogen gas or metal will be produced. If the metal is above hydrogen in the reactivity series, the hydrogen will be produced and bubbling will be seen at the cathode. This is because the ions of the more reactive metal will remain in the solution, causing the ions of the least reactive metal to be discharged. Therefore, at the cathode, hydrogen gas will be produced unless the positive ions from the ionic compound are less reactive than hydrogen, in which case the metal is produced. This is the reactivity series of metal, including hydrogen and carbon. We have potassium, sodium, lithium, calcium, magnesium, aluminium, carbon, zinc, iron, hydrogen, copper, silver, and gold. Well, Daniel, are you there?
Yes, I'm here.
Okay, so we'll hand over to you.
Okay, so for aqueous copper sulfate, the aqueous copper sulfate contains the following ions, which is copper, sulfate, hydrogen, and hydroxide. At the cathode, copper and hydrogen will both be attracted to the cathode, but the less reactive ion will be discharged. In this case, copper is less reactive than hydrogen. Copper ions are discharged at the cathode, gain electrons, and are reduced to form copper metal. The half equation for the reaction at the electrode is Cu plus 2 electrons. Cu, the ion of the copper plus 2 electrons gives you copper metal. At the anode, sulfate and hydroxide are both attracted to the anode. Hydroxide ions lose electrons more readily than sulfate ions. Sulfate. Hydroxide lose electrons and are oxidized to form oxygen gas. The half equation for the reaction at the anode is hydro
For all hydroxide will give us
oxygen
oxygen. Yeah.
and the addition of 4 electrons.
Okay, so this is the aqueous solution, ions present.
They are lagging.
Yep, sorry. So when we have product at anode and product at cathode, so when they have concentrated sodium chloride NaCl, at the anode chlorine gas will be released and at the cathode hydrogen gas will be released. When it's dilute sodium chloride, oxygen will be produced at the cathode and hydrogen gas will be released at the oxygen will be produced at the anode and hydrogen gas will be produced at the cathode. Concentrated aqueous copper sulfate, oxygen gas released at the anode, and copper is lower than hydrogen in the reactivity series, so copper is preferentially discharged as a metal. Dilute sulfuric acid, oxygen will be released. H2 more readily gives up electrons than SO4 at the anode, and hydrogen gas is released at the cathode. Moving on to ionic half equations. Daniel, would you like to take over?
Sure. In electrochemistry, we are mostly concerned with the transfer of electrons. Hence, the definitions of oxidation and reduction are applied in terms of electron loss or gain, rather than the addition or removal of oxygen. Oxidation is when a substance loses electrons, and reduction is when a substance gains electrons. As the ions come into contact with the electrode, electrons are either lost or gained and they form neutral substances. These are then discharged as products at the electrodes. At the anode, negatively charged ions lose electrons and are thus oxidized. At the cathode, the positively charged ions gain electrons and are thus reduced. Ionic half equations show the oxidation and reduction of the ions involved. It is important to make sure that the charges are balanced. This is the table for the reduction and oxidation of at the electrodes. For molten lead bromide, bromine will go at the anode and gain two electrons. At the cathode, lead will go and gain two electrons to form lead metal. For concentrated aqueous sodium chloride, chlorine will go to the anode and form chlorine gas due to the addition of two electrons, and at the cathode hydrogen will form hydrogen gas due to the addition of two electrons. And for dilute sulfuric acid, hydroxide will go to the anode to form oxygen and water due to the addition of four electrons or the loss of four electrons. Then at the cathode, hydrogen gains two electrons to form hydrogen gas. Here's a tip for the exam. To help you remember the definitions of oxidation and reduction, use oil and rake. Oxidation is loss of electrons, reduction is gain of electrons.
Okay. You guys, electroplating will be done in the next video. I hope you enjoyed our video with Daniel today. So make sure to like, share, subscribe, and see you in the next video. Till then, ta-da!